Okay, hi everybody. I just wanted to make sure we talked about anabolism and then the summary part of the metabolism topic that we didn't quite get to make time for the pie competition in last week's class. So we'd been talking about catabolism, so breaking down storage molecules into smaller components that then can be burned to produce ATP. But through your day, you go through periods of anabolism. So generally after a meal, you have anabolic responses. That is, you store up all those macronutrients that you've taken in to your body. So we had talked about carbohydrates turning into fat, and generally speaking, they don't do so directly, although that can happen. But if you have an excess of carbohydrates, you will burn those instead of burning a 50-50 mix of carbs and fat as you would normally. And so you do have increased fat stores from all that carb intake, but the carbs aren't directly turning into fat. Fat is stored as fat, so that's easy. So carbs are burned in preference for fat if carbs are in excess. If fat is in excess, it just becomes fat. And that leaves protein, which is what's shown on this slide here. And what this slide is just showing you is that you can make amino acids from other amino acids. The exception to this, of course, is that you can't make essential amino acids. That is, by definition, the essential amino acids are the ones that you have to consume. So when your body's building protein, it takes a combination of amino acids that you have just consumed, and then amino acids you already have, which it either uses as is or converts them through these so-called transamination reactions into the ones that it needs, and builds protein from there. As we've discussed before, protein-based tissue is built as it's needed, so eating more protein won't cause more of these reactions to happen, unless you'd been eating too little protein to begin with, which again is really only likely if you hadn't been eating enough total calories, since you only need a relatively small intake of protein in order to have enough amino acids to do this. Okay, so that's building up. And then the last thing that we would have done if we'd had a few more minutes in class is to sort of put it all together with a couple real-world situations. So if you ate a big meal, what's happening with insulin and glucagon, and what's happening to the carbs, fat, and protein that you ate? So you can always think about this figure, really like go have a cup of tea with this figure and really, make it make sense to you, see what's happening there. And this doesn't refer to any particular state like after a meal or before a meal, but it shows you all the things that are possible. So if we go back to our question, well, after a meal, you're going to have carbs and amino acids and fatty acids going into your blood, carbs, fat, and protein going into your blood. And so this is an anabolic time. A time we'll be storing up energy. And your major anabolic hormone is insulin. So insulin, in response especially to the glucose level increasing as you absorb the sugars in your food, insulin will direct that sugar to be taken into cells to burn for energy. It also increases the degree to which cells take in and burn fatty acids. We don't often talk about that with reference to insulin, but it's anabolic actually with respect to all three macronutrients. It also stimulates the protein that you ate to be stored. Protein can't be stored as protein, but the amino acids are kept in amino acid pools in relatively small amounts. And any excess protein, as we talked about in the protein chapter, will be converted to fat. And from there it can be stored or burned. So you don't put excess protein on your body as protein. If it's in excess, it will be converted into fat. So your insulin will be high to put away all these nutrients that you ate. Your glucagon level would be low. Glucagon is a catabolic hormone, so it comes out when you need to increase the amount of energy molecules in your blood, but you just ate a lot of stuff, so that's going into your blood. So glucagon's low. The carbs are being burned. That's their primary role, is to be burned for energy. The fat, depending on the fat to carbs ratio, is either being stored as fat or burned, converted to carb and burned, converted to acetyl-CoA and burned. And the protein is either being distributed to the amino acid pools around your body and beyond that converted to fat. And you can see all these different possibilities here in this figure. So if you look down here where these amino acids are, right, they can be built into the functional proteins in your body. They can be kept in the amino acid pools, which are just kind of, these are the pools there as shown in this picture. Or they can be made into acetyl-CoA, which can then be converted to fat and stored. Okay, now in the opposite situation, what if you then didn't eat for the rest of the day? So now you're in a state where all the nutrients in your blood are dropping and you need to increase them again. So now we have the opposite situation with insulin and glucagon. Insulin will be very low. Its purpose is to build up ingested nutrients. We don't have any of those. We're not eating. So glucagon will come to the rescue and make sure that the blood has enough glucose in it, and also that amino acids be released into the blood. And that fatty acids are released into the blood from storage. So your fat will begin to, stored fat will begin to be released. The carbs will be being burned, and quite quickly. There won't be any carbs left, but over the course of a day, you'll still have carbs left. You have some glycogen in your tissues, and so that will supply carbohydrate for the rest of that day. The fat is gradually being released from the stores of fat in your adipose tissue. And nothing much is happening with protein. So you have some amino acids that are available, but your protein-based tissue, your muscle, won't be affected by not eating for a single day. Now, over the course of a whole week, what's happening to all these things. So if you truly, were starving, you didn't have any food to eat for a week, again, we would expect insulin to be highly suppressed, glucagon to be very active, trying to keep enough nutrients in your blood to keep you alive by breaking down stored energy. You wouldn't have any carbs at all left within a couple days. You'd have used up all your stored glycogen, so there wouldn't be any carbohydrate, being released from your body. You would have fat being converted, maybe not exactly to carbohydrate, but to acetyl-CoA to be burned with. So the carbs in your body are gone. The fat is being burned, and generally speaking, the protein again will not. Some of it is converted into burnable molecules for your brain, but overall fat is going to be providing most of the energy supplies. And this is a good figure from your book that shows what happens during starvation. So if you look down here in the bottom left, you'll see your carbs started out really low, and then they went to zero, within a couple of days. This is 1 week, so within a few days after you stopped eating, you don't have any carbs in your body at all. The fuel use shifts to fatty acids and ketone bodies, which, remember, are what happens when you don't have enough carbs to burn fat the usual way, is that you end up with these ketone bodies, which can also be used. So this here is your stored fat, this yellow line, okay? And you can see that that's by far the most stored energy you had in the first place, right? You had a tiny bit of carbohydrate, you had some protein, and you had a lot of fat. So all that fat gets gradually broken down. This is broken down. This is the steep line, right? So it's fat that you're burning as this week goes on. And after 1 week of starvation, you have almost no change in the amount of protein in your body. It starts to go down really slowly if you starve for weeks and weeks and weeks, and really doesn't start to go down sharply until you run out of fat or almost run out of fat. So basically, if you starve for a week, what's happening is you're burning fat. Because that's how energy is stored on our body. So that's how that's the energy that we access when we need it. All right, if you have questions about any of this stuff, just let me know. Remember, there's 2 review sessions this week, and you can also come to my office hours and email me, and I'll also be there before the exam on Friday because there's no class before ours, so we should be able to have access to that room with time for me to answer questions before that begins. Okay, bye.